and we'd get to be the Voyagers, the Star Trek people, the starship builders, the policemen, and so on. It is the nature of intelligent life to destroy itself. This is the argument that technological civilizations may usually or invariably destroy themselves before or shortly after developing radio or spaceflight technology. The astrophysicist Sebastian von Hoerner stated that the progress of science and technology on Earth was driven by two factors: the struggle for domination and the desire for an easy life. The former potentially leads to complete destruction, while the latter may lead to biological or mental degeneration. Possible means of annihilation via major global issues, where global interconnectedness actually makes humanity more vulnerable than resilient, are many, including war, accidental environmental contamination or damage, the development of biotechnology, synthetic life like mirror life, resource depletion, climate change, or poorly designed artificial intelligence. This general theme is explored both in fiction and in scientific hypothesizing. In 1966, Sagan and Shklovsky speculated that technological civilizations will either tend to destroy themselves within a century of developing interstellar communicative capability, or master their self-destructive tendencies and survive for billion-year timescales. Self-annihilation may also be viewed in terms of thermodynamics, insofar as life is an ordered system that can sustain itself against the tendency to disorder. Stephen Hawking's external transmission, or interstellar communicative phase, where knowledge production and knowledge management is more important than transmission of information via evolution, may be the point at which the system becomes unstable and self-destructs. Here, Hawking emphasizes self-design of the human genome, transhumanism, or enhancement via machines, e.g., brain-computer interface, to enhance human intelligence and reduce aggression, without which he implies human civilization may be too stupid collectively to survive an increasingly unstable system. For instance, the development of technologies during the external transmission phase, such as weaponization of artificial general intelligence or antimatter, may not be met by concomitant increases in human ability to manage its own inventions. Consequently, disorder increases in the system. Global governance may become increasingly destabilized, worsening humanity's ability to manage the possible means of annihilation listed above, resulting in global societal collapse. A less theoretical example might be the resource depletion issue on Polynesian islands, of which Easter Island is only the best known. David Brin points out that during the expansion phase from 1500 BC to 800 AD, there were cycles of overpopulation, followed by what might be called periodic cullings of adult males through war or ritual. He writes, "There are many stories of islands whose men were almost wiped out, sometimes by internal strife, and sometimes by invading males from other islands. Using extinct civilizations such as Easter Island, Rapa Nui, as models, a study conducted in 2018 by Adam Frank et al. Posited that climate change induced by energy-intensive civilizations may prevent sustainability within such civilizations, thus explaining the paradoxical lack of evidence for intelligent extraterrestrial life. Based on dynamical systems theory, the study examined how technological civilizations, exo-civilizations, consume resources and the feedback effects this consumption has on their planets and its carrying capacity. According to Adam Frank, the point is to recognize that driving climate change may be something generic. The laws of physics demand that any young population building an energy-intensive civilization like ours is going to have feedback on its planet. Seeing climate change in this cosmic context may give us better insight into what's happening to us now and how to deal with it. Generalizing the Anthropocene, their model produces 4 different outcomes. Die-off, a scenario where the population grows quickly, surpassing the planet's carrying capacity, which leads to a peak followed by a rapid decline. The population eventually stabilizes at a much lower equilibrium level, allowing the planet to partially recover. Sustainability, a scenario where civilizations successfully transition from high-impact resources, like fossil fuels, to sustainable ones like solar energy, before significant environmental degradation occurs. This allows the civilization and planet to reach a stable equilibrium, avoiding catastrophic effects. Collapse without resource change. In this trajectory, the population and environmental degradation increase rapidly. The civilization does not switch to sustainable resources in time, leading to a total collapse where a tipping point is crossed and the population drops. Collapse with resource change. Similar to the previous scenario, but in this case, the civilization attempts to transition to sustainable resources. However, the change comes too late,